Okay, so we're starting a brand new unit today. What is a polyhedron? This is our last unit of the year. We're going to do it this week and next week. During class this week, we're going to have a second assignment reviewing for the final, but we're going to be doing a study guide or two, a quiz, and a review assignment on the Tuesday, Wednesday class and on the Thursday, Friday class. So you'll have a review for the final, and you'll have these new unit assignments. So a polyhedron is a three-dimensional solid bounded by polygons called faces. The faces of the polyhedron are the sides that are facing out. It encloses a single region of space. Okay, making mental images and organizing information. Let's complete this little chart. The parts of the polygon that we need to remember. We've got the vertex, which is a point. Some of you might think of it as a corner. And then we've got the edges of the polyhedron, and that's a line segment. And then we've got the faces. Right below that, we're going to go label one of each so you get a visual of this. So pick any corner. I'm going to pick this one right here. And go ahead and label that as the vertex. That is a vertex of a polyhedron and of the polygon face. Go ahead and pick any edge. I'm going to pick this one and label that an edge. Do you see that line segment? And then go ahead and pick any face. I'm going to pick this one right here that I'm shading green and label that the face. Are there any questions so far on these parts of the polyhedron? The faces are all those sides that we can see. The edges are all the lines at the edge, and the vertex are all the corners of this shape. Okay, again, if I'm going too fast, this key will be provided for you at the end, but let's keep up. All right. How are oblique and right polyhedrons different? So here's two new vocabs. Oblique, you guys can see the spelling right there in the question. Polyhedrons are slanted. Right polyhedrons are upright. If you want to go Google an image of a slanted polyhedron and oblique, or of a right polyhedron to visualize, feel free to do that. Okay, a prism. Here we go, some more vocabulary. A prism is a polyhedron made of two solid hang on. The solid goes over here. A polyhedron or a solid made of two parallel congruent polygons, and that are all the points between them. So a prism is a polyhedron or a solid that is made of two parallel congruent polygons and all the points between them. The two parallel congruent faces like a top and a bottom. The lateral faces, like the bases, all rectangles that are not bases. And then an altitude, the line segment whose length is the height of a prism. So here are some pictures of prisms below. So if you're like, I don't know what any of these words mean, you know, a solid that has two parallel congruent polygons, blah, blah, blah. Well, look at the pictures below. These are prisms. Prisms are named for its bases. So this red prism, this is known as a triangular prism. Notice the one on the right that's green. It's known as a rectangular prism. Why are they called that? Because that's the shape of their bases. So if the base is a triangle, it's a triangular prism. If the base is a rectangle, it's a rectangular prism. Please let me know if I need to go back to a section that you still needed. All right, let's compare a line segment and a prism. A line segment is 2 points and all the points between it. So a line segment is 2 points and all the points between it. Right here, right here, right here, right here, right here. You know what a line segment is. You can visualize it. And a prism is now 2 bases and all the points between them. Look up at the pictures above at the rectangular prism and the triangular prism. That's our new concept for the rest of this unit. This is what we're going to be studying, polyhedrons. Why can any 2 opposite faces of a rectangular prism be called the bases? Because all the faces of that shape are rectangles. All the faces are rectangles. And then why is a cube a special kind of rectangular prism? You guys can imagine a cube is a square on all the sides. All its faces are congruent. Rectangles, or all its faces are squares. How are oblique prisms and right prisms different? And again, this is still going back. We just wrote it a second ago. Oblique prisms are slanted. And right prisms have 2 bases that are perfectly aligned. So while you're finishing writing all of that, I'm going to fill in this little Venn diagram with our word bank. What we're studying this unit is 3-dimensional objects. 3-dimensional. And the overarching term that we just learned is polyhedrons. I'm going to zoom in on this in a little bit when people are done writing the top. And now we just got this word prisms, which are a type of polyhedron. And we now know that there are rectangular prisms. And we know that there's the most special, a cube. So this is a lot of writing. I'm going to pause here for a second. Make sure you've had time to write all these down from this 7-1 study guide so far. On the next page, they give us a word bank, all of these words that we just wrote in the Venn diagram. And then just as a quick, well, what are some real world examples of this? You can write anything you want on these lines that you can think of. But for example, a brick would be an example of a real world rectangular prism. A roof would be a triangular, well, on most houses, I should say. A shoebox, I don't know. Think of things around your house that are shaped like a rectangular prism or like a triangular prism. Okay, finally here, let's start talking about pyramids. A pyramid is a polyhedron or a solid made up of only one base, and then it goes up to a point not on the same plane. And of course, it's all the points in between it. So picture this time that you've got some sort of a base that goes up to a point or a vertex. And this is going to be forming our pyramid. Don't worry, there's going to be a better picture coming below. It has one polygon base, like a rectangle or a square, one polygon base, like a bottom. And then all of its lateral faces are triangles. All of its lateral faces are triangles. And its altitude is the line segment whose length is the base of the pyramid. Its altitude is the line segment, and its length goes the whole base of the pyramid. Take a minute to make sure you have this written in before I go on to the next slide, next page. Okay, so of a regular pyramid, the base is a regular polygon. What does regular mean? It means all same length sides, right? Regular, all same length. So if it is a regular prism, it has all the same length. It's made up of bases that are regular polygons. So hang on, same length sides. So that means the base could be a square. The base could be a rhombus, but it's got to have all the same length, a regular polygon. The lateral faces are all congruent. The vertex is centered over the base, and the altitude goes through that center, straight down to that base. Okay, compare a line segment to a pyramid. We know that a line segment has 2 points and all the points in between. We just wrote this before when we were talking about prisms. And now we're talking about a pyramid that is a polygon and a point not on the same plane and all the points in between them. So picture how we just visualized the prisms. Now we're going to go look at these pyramids. Let's look at 2 different pyramids, this orange and this blue one. And we're going to notice that the base on the left one, the orange one, the base is a triangle. And so this would be called a triangular pyramid. On the right-hand side, we're going to notice that the base of this one is a rectangle. And so this would be called a rectangular pyramid. And doesn't this one look like a pyramid? If you picture like the pyramids of Egypt, we're like, oh yeah, pyramid, got it. Now I can visualize it. So think about those prisms. They have 2 polygons as the base. And think about this pyramid. It has 1 polygon as the base with a vertex at the top. Okay, why is a triangular pyramid a special kind of pyramid? Because any face can be treated as the base. Can you picture holding a triangular polygon and how you could roll it from side to side to side, and the side it lands on could become the base? Any face can be treated as the base when it's a triangular pyramid. Any face. That's what makes it special. How are oblique pyramids and right pyramids different? Again, oblique pyramids are slanted. And right pyramids, the vertex is centered over the base. And finally, they give us a little Venn diagram here at the bottom where you're just going to fill in that prisms, it's formed by congruent polygons. And pyramids are formed by similar polygons. But they're both formed by a pile or stacked polygons. So on this side, if I stacked a rectangle on top of a rectangle on top of a rectangle on top of a rectangle, it would make my prism. And on this side, if I stacked a triangle with a smaller triangle, a rectangle with a smaller rectangle with a smaller rectangle, similar rectangles all the way up to the top until the vertex, except for the vertex, it would make my prism. This is the end of the study guide for the 7.1. Notice there's no checkup because it was all vocabulary. Did you guys see that? And so it's leading us right into the 7.2 now. So go ahead and finish writing this so you can be ready for the 7.2. By the way, when you guys go into Apex this time, you're going to notice that you need to go into the Unit 7. We've passed the Unit 6. I'm going to be progressing you through the Unit 6 quizzes that you guys never finished. So if you're somebody who never finished a quiz from last unit that was supposed to be done by last Friday, you're going to want to quickly do that before I close it out, because we're going to be doing Unit 7 tonight for homework. Okay, so now our study starts with cylinders and cones for the 7.2. I just want to show you what I'm going to be finishing here. We're on page 365, 366, 367, and 368 that we're going to fill in. And notice again that there's no checkups. It's just a study guide. And the 7.2.3 quiz is your homework. So that's what you guys are going to do tonight after completing these study guides with me. Okay, so let's go do the parts of this cylinder here in this picture. All right, go ahead and label right here. Hey, stuff I know, circles from last chapter. There's my radius of the top of the cylinder. Inside there is known as the altitude. And at the bottom, we have the base, which happens to be a circle. So a cylinder is a solid made from two congruent and parallel circular bases and all the points in between them. I don't know why there's like an S over there. The parts of the cylinder are the radius, the altitude, and the base. Those are all important for calculating area, surface area, and volume, etc. Okay, what are some real world examples of cylinders? I don't know. You guys want to throw one out there? Maybe like a can of paint. Maybe like a water bottle. Maybe a roll of coins. Piece of chalk. If you have ever written on the sidewalk with a piece of chalk, that's a nice little cylinder. Anyways, you can write anything down there if you think of something different than mine. No biggie if you don't write it down at all, but just to kind of give you something to visualize. So talking about these last shapes that we're going to do today before you go take your quiz, polyhedron bases are polygons again. This is for prism. And a cylinder, the bases are circular, which is kind of different, or discs. They are circles. And so it's not a polyhedron. But they do both have two congruent parallel bases. But this guy over here might have a rectangular base. And you'll notice that that's connected down. To rectangular base. And then a cylinder has two circular bases that are connected down. Okay, so this is not circles. Cylinders are not a polyhedron. Keep that in mind. So we grow the cylinder from its base when we're picturing it being formed because it's stacked with congruent discs. Picture that being grown. And then we enclose the cylinder with its bases and its lateral face. And the two bases are congruent discs. The top and the bottom are congruent. And then the lateral face is like a rectangle rolled around those bases. So picture if I took a rectangle and then I rolled it around, it would make that circular shape around the two bases. So that's a cylinder. And now we're going to talk about a cone. A cone is made from one circular base and a vertex not in the same plane. So notice this time, instead of two circles around the top and the bottom, you've got the vertex up here. You've got the altitude still inside, and you've got the base down here. Three real-world examples of a cone, maybe like party hat, New Year's hat. maybe like an ice cream cone. I don't know. I'm trying to think of like a snow cone cup, an ice cream cone, a traffic cone. Those are examples of real world cones. And then they've got your little Venn diagram here again to say what's similar with a pyramid and a cone. The polyhedron base of a pyramid is a polygon. And the cone is not a polyhedron. The base is a circular disc. But both solids have one base with one opposite vertex. So picture like a pyramid has that point at the top and a cone has the point at the top, but one of them has a base that is a square, some sort of polygon at the bottom, and one has a base that's circular. We still grow the cone from its base, and we stack similar discs until it gets to the top of the vertex. Base 1 is a disc, and then the lateral face, one section of what's wrapped around, is a circle. So now just go draw yourself some images. Here are some bases. Here are some vertices. Those are the little points at the top. Here are some right and oblique cylinders. Can you see the slanted one? And can you see the upright one? That's the right and the oblique. And then over here you can see the right and the oblique. Cones. Notice what it looks like standing upright. Notice what it looks like slanted. And then quickly finishing this off, because I don't want you guys to have to stay on here too long, go label the vertices on this next one. Go label the bases on this next one. These are right and oblique pyramids. And these are right and oblique prisms. And so finishing off this big book notes, your cone has one disc and one section of a circle. Your cylinder has two discs and one curved rectangle around it, making the lateral face. A prism has two polygons, top and bottom, and at least 3 rectangles. And a pyramid has one polygon at the bottom, the base, and at least 3 triangular faces.